Okay, chapter 8 begins with inequalities. We're going to start with kind of a review of inequalities in one variable before it eventually becomes inequalities in multiple variables and how we address this issue. So some rules for inequalities. Adding and subtracting doesn't change the direction of the inequality. Multiplying or dividing by a positive number doesn't change the direction of the inequality, but multiplying or dividing by a negative number does reverse the direction of the inequality. Now, one thing to note, for less than or greater than, when you're using your solution set interval notation, use parentheses. Less than or equal to or greater than or equal to uses brackets. So let's remind ourselves how this works. So when you're graphing an inequality in one variable, you use a one number line. Y is greater than 3. Start a number line, find 3. Which direction is greater than? To the right. Because it's just greater than, we either use an open circle and go to the right. Your homework will either use this, open circle for greater than or less than, filled in circle for equal to, or sometimes it uses this instead, a parentheses instead of a bracket to indicate, again, either one of these. I don't remember which one your homework uses, but they mean the same thing. 3 is less than or equal to x is less than 5. Again, that means x values between 3 and 5. An open circle on 5 because it's only less than 5. But for 3, because the equal sign, we would close the circle and the line continues. We don't have an arrow here because it's sandwiched between two values. It doesn't go on forever. The equivalent version with parentheses and brackets would be a parentheses at 5, but a bracket at 3, and the line filled in between them. Okay, so now that we've seen generally what these look like, let's solve some inequalities and make sure we're doing them right. 3x minus 8 is less than or equal to 7, add 8. 3x is less than or equal to 15, divide by 3. X is less than or equal to 5. Okay, so it says write each solution set in interval notation and graph it. So graphing it, start at 5, and I'm going to use the circle representation. Less than means to the left, goes on forever. Now how does this translate into interval notation? It's all numbers that are less than 5. So 5 is our highest value, so it goes at the end of our interval. All the numbers less than 5, it goes on forever to the left. So that goes to negative infinity. So if you're going on forever, you're either going towards negative infinity or positive infinity. And since they are both concepts and not actual numbers, the infinities always get parentheses regardless, because you can never actually get to infinity. Let's look at number 4. To clear the divided by negative 4, I have to multiply by negative 4 on both sides. Remember that when I multiply by a negative number, it changes the direction of my inequality. So now we have 2x minus 5 is less than negative 20. Add 5. 2k is less than negative 15. Divide by 2. K is less than negative 15 halves. Okay, so let's talk about a graph. We have negative 15 halves. Open circle, it's going to the left. Same idea behind the one up here. We start at negative infinity, go to negative 15 halves. This one only gets a parentheses because it's only less than. Now for reference, negative 15 halves is between negative 7 and negative 8 if you weren't sure. But for graphing purposes, if it's a multiple choice on the homework, you should know where it is. 2 is greater than negative 6x minus 3 is greater than negative 3. Add 3 to all 3 sides. If there are 3 sides, you just do the same thing to all of them. 5 is greater than negative 6x. It's greater than 0. Divide by negative 6. So again, dividing by a negative changes the direction of the inequality. Negative 5, 6 is less than x. It's less than 0. So on a graph, we've got negative 5, 6 and 0. Both open circles, and the line connecting them in the middle. And lastly, for interval, it's easy when it's sandwiched between two values because those are our two outside numbers. It's negative 5/6 and 0, and they both get parentheses because they're both open circles. Okay, so let's look at some word problems that go with this. Solve the problem. Scott Barnes scored 92 and 96 on his first two tests in methods in teaching mathematics. What score must he make on his third test to keep an average of 90 or greater? So the sum of all of his, or the average of all of his scores must be greater than or equal to 90. This means 92 plus 96 plus his third score divided by 3 is greater than or equal to 90. Now why is this on the left? Remember, to average three things, you have to add them all together and divide by 3. So we know 2 of them and we don't know the last one. So let's solve for x. Multiply, we can combine those two. This is 188 plus x over 3 is greater than or equal to 90. Multiply by 3 on both sides. So 188 plus x is greater than or equal to 270. This doesn't change direction because it was multiplying by a positive. Subtract the 188. You said x is greater than or equal to 82. So really this means Scott must get at least an 82 on the third test. And lastly, Speedy Delivery finds that the cost to make X deliveries is 3x plus 2,300, while the revenue is 5.5x, where C and R are in dollars. If a profit occurs only if revenue exceeds cost, find the least whole number of units X that must be sold for each business to show a profit. So profit occurs when revenue exceeds cost, so I need 5.5x, 550, to be greater than 3x plus 2,300. Subtract 3x. 2.5x is greater than 2,300. Here we can multiply by 2. The reason I'm going to do that is it'll clear the 2.5. So this is 5x is greater than 4,600. Divide by 5. X is greater than, it looks like, 920. So you have to sell more than 920 units. But the question is, find the least whole number of units that must be sold for the business to show a profit. So what's the next whole number above 920 that they're going to have to sell in order to make a profit? The next one above 920 is 921 units. Must, or more, must be sold to make a profit. And that is all for 8.1.